Let's work through this question to develop an understanding of the units on average rate of change. Usain Bolt is running in the heat of a 200-meter dash. His distance from the starting line can be modeled by m of t equals 1/2 t squared meters, where t is time in seconds. What is his average speed between 2 and 6 seconds? So before we do anything with average speed, let's just remind ourselves of the units on the function and the input. So m of t has units in meters. Right? The function has units in meters in this case. And the input, t, has units in seconds. Okay? So average rate of change, or average speed, and here speed is the rate of change of distance per time. So the average speed really is the same in this case as the average rate of change. Will be, well, it's the function evaluated at the second t coordinate, because t is our variable, so it's m of 6, minus the function evaluated at the first t coordinate, m of 2, divided by the second t coordinate minus the first t coordinate. Right? So that's the formula for average rate of change. But we have to be careful because we're working in a real-world question with units. Right? Here m of 6 is a distance in meters, and m of 2 is a distance in meters. So the whole numerator has units of meters. And in the denominator, 6 is not just the number, it really represents 6 seconds, and 2 represents 2 seconds. So the denominator has units of seconds. So the average rate of change has units of meters per second, which is exactly what we would expect for something like average speed. Units would be something like meters per second. So what you need to remember is whenever you're looking at the average rate of change, that the units on the average rate of change are, well, it's a fraction. It's the units of the function divided by the units of the input. Right? In this case, the units of the function were meters, and the units of the input were seconds. So the units of the average rate of change were meters per second. Now there are lots of different functions with various different units, and as long as you're careful and you look at what the units of the function are, and when you look at what the units of the input are, you can always determine what the units of the average rate of change are. So I haven't solved this question, I've merely set it up. So what I would like is for you to solve this question, right? Hit pause, work through the question just for a little bit of extra practice on the average rate of change, and then come back, hit play again, and we'll solve it together just to check your work. So go ahead and hit pause now. Okay, hopefully you've hit pause and worked through it. So let's work through this average rate of change, and in particular, make sure that I don't forget to include the units at every step. Okay, so our function m of 6, the function is 1/2 t squared. So it's 1/2 times 6 squared minus 1/2 times 2 squared, all divided by 6 minus 2. And since it's a real world question, I need those units there. So 6 squared is 36, and if I multiply that by 1/2, I get 18. 2 squared is 4, and if I multiply that by 1/2, I get 2. And then 6 minus 2 is just 4, and again, meters per second. So I get 16 over 4 meters per second, or in this case, 4 meters per second. So on average, his average speed between 2 and 6 seconds, right, speed was 4 meters per second.